Multiple choice, question 5. Which quantities can be written as kilograms per meter per second squared? You just have to work through here. So if we look at kinetic energy, that's a half mv squared. So we have mass meters squared per second squared. So that's no good. So that's Ka. That means A can't be right. But tensile stress comes up in 2 of these. So let's do stress then. Stress is force over area. Force is mass times acceleration divided by meters squared. So that is kilograms per meter per second squared. So tensile stress, that works. So we know that it can't be A. Moment and Ke, well, we know Ke is wrong, so that's not going to work. Young's modulus and moment. Well, Young's modulus, that's FL over AE, if you remember. So that's force, kilograms meters per second squared, times meters, over meters squared, times meters. So that's meters cubed. That gives us kilograms, meters divided by meters cubed, is per meter squared, times meters per meter. So that's kilograms per meter per second squared. So Young's modulus works. So we know Young's modulus works, we know stress works. The answer is D. So you just have to work through these. Some of them are faster than that. Question 6 then. Which graph of neutron number against proton number for the isotopes of a given element? So isotopes, same atomic number, different mass number. So Z is fixed here, so it has to be D. Question 7. We have P goes to Q by alpha, Q goes to R, and then R to S by beta minus, and then S to T by alpha. Which statement is correct? P and S are isotopes, so they'd have the same proton number. So P and S, we have gone down 2, up 1, up 1. So there it is. The answer is A, because they are isotopes. We're certain about that. You could go through and check the other 3, but definitely P and S are isotopes. Question 8. Bit of particle physics here. Which rule gives a particle with its quark combination and category? So the question is the pion a baryon, a hadron, or a meson? And do these quark combinations give us the right charge? So it's not a baryon because we've only got 2 quarks, so we can rule out A. So we're down to hadron or meson. And it's not going to be up, anti-down, because that gives you a positive charge. So that can't be right. So it is a hadron, it is positive, and therefore it's B. Question 9. Which rule gives the number of baryons, that's protons and neutrons, and leptons, that in this case is electrons. In carbon 12, well, that is 12 baryons and 6 leptons, B. Question 10. A muon, is it subject to the strong interaction? Well, no, because the strong interaction acts on quarks, and muons are not quarks. Can decay an electron only? Well, no, it will decay into an electron and a pair of neutrinos, so that's not the case. Is stable? Well, no, because it does decay. Subject to the weak interaction? Well, yes, that's easy because everything is. Question 11. Photons of energy 1.0 × 10⁻18 joules incident on a metal surface and cause the emission of electrons. Which statement is correct? Electrons have a Ke of 1 × 10⁻18. No, because there will be a work function. They each have a Ke of a multiple of that. Well, that violates conservation of energy, so that's not true. They have a mean Ke of that. No, because of the work function. The Ke of each must be less than. Yes, because of the work function. The work done in removing an electron from the surface of the metal. Question 12. Evidence of wave-like properties. Emission of electrons when short wavelength light falls on a metal surface? No, that's particle behaviour. The movement of electrons in electric current? Particle behaviour. Diffraction of electrons? Well, diffraction is a wave property. So the answer is C. Annihilation, well, that's particulate. Question 13. An approximate average Ke of a cyclist. Well, if we said our mass was 100 kilos, say, we would have a half times 100. Let's say it's traveling at 5 meters per second, 25. So you've got 12 and a half times that. It's about 12 and a half. 1,250. 12,500. So we are looking at 10 joules, no. Megajoules, no. Terajoules, no. Probably kilojoules. So B. Question 14 then. Diagram shows energy levels in an atom drawn to scale. Transition from 4 to 2 gives us green light. We want to know what would give us red light. Well, red light has a longer wavelength, lower frequency, less energy. So less than 4 to 2. So 2 to 1, that's too big. 3 to 1, definitely too big. 3 to 2, well, 3 to 2 is definitely smaller than 4 to 2, so 3 to 2 would do. 3 to 2 is C. Question 15 then. A sonar transmitter on a ship produces pulses of sound wave. Each pulse contains 12 complete oscillations. The frequency of these waves is 8 kilohertz. And the speed of sound is 1.5 times 10 to the 3. We want to know what is the length of one pulse, which is 12 wavelengths. So lambda is V over F, which is 1.5 times 10 to the 3, divided by 8 times 10 to the 3. And then the length is 12 times lambda. So if we do all that, for 15, we get 2.25, which is B. Question 16. which regions of the EMS are in increasing wavelength here. X, ultraviolet, infrared, radio, that's the one. A17. The frequency of the first harmonic is that the tension is doubled. Well, if you remember, F is proportional to the square root of the tension. So what we're doing is the frequency is going from the frequency to root 2 times the frequency. So if we do that, we end up with 420. We have double slit experiment. Spacing is S, distance between the slits in the screen is D. When monochromatic light of wavelength Y is incident on the slits, the distance between the adjacent fringes on the screen is W, which row shows another arrangement that produces a fringe spacing of W. Well, we have lambda equals XS over D. Lambda is possibly doubled, so we'd have to have doubled here. 4S and 2D would do that. And you could check the others, but the answer is A. 19. Was the highest order maximum produced? Well, you're going to say that d sine theta equals n lambda, which leads you to n is d sine theta over lambda. Sine theta has a maximum of 1, so if we do d over lambda, we get 5.7. You can't have 5.7, so the answer is 5, and that is A. Question 20. What changes with refraction? Not frequency. Speed and wavelength, C. 21. What is a description of the pattern produced when monochromatic light passes through a very narrow slit? Well, you would expect a wide central maximum with narrow side fringes, would you not? I certainly hope you would. 22. Uniform picture suspended from a string. So we've got two strings at 30 degrees, or a string at 30 degrees on each side. So you would say, put 22 down here, 2t sine 30 equals 20 newtons. That's the vertical component of the two tensions, equal to the weight. Sine 30 is a half, so t is 20 newtons, and the one that corresponds is C. 23. Vectors, only vectors, yes, no, yes, yes, no, yes, no, no. Displacement momentum, B. 24. Uniform rod is balanced horizontally about a support F. Forces of 400 and 100 newtons act at the ends as shown. What is the reaction force? Well, we have two unknowns here. We have the weight of the beam that we don't know. Notice it doesn't say a light uniform rod or a uniform rod of negligible mass. It is a uniform rod. So we don't have the weight, but it's uniform, so we know where the weight acts. Bang in the middle, 2 meters. So if we take moments about the pivot, we've got 400 times 1. And that equals the weight times what is going to be 1 meter away plus 100 times 3. So the weight then is 100 newtons. And then we do our sum of forces equals 0. Maybe I shouldn't use F. Sum of forces equals 0. So we have 400 plus 100 for this 100 here, plus the 100 that is the weight of the beam. That has to equal F upwards. So F is 600 newtons. Oops. And 600 newtons is answer D. So, fair bit of work involved for 1 mark there. And you got to read the question carefully. 25 then. I don't like question 25. 3 objects U, V and W leave the edge of the bench at the same time. We know that the time it will take them to fall will be the same. They will all arrive at the ground at the same time. That's because there is no air resistance and they're all going the same distance under the same gravity. So they'll all arrive here at the same time with the same vertical velocity. But W has the biggest horizontal velocity, and so W will have the biggest speed when it hits the ground. So the answer to 25 is C. But I don't like it. I prefer it if it was written in terms of velocity. 26. Railway truck, mass 2,000 kilos, travelling horizontally at 1.5 meters per second, collides with a stationary truck and they move together. What is the speed of the trucks after the collision and the effect on the KE? Well, the KE will definitely decrease. It has to be B or D. We know that. So we would say conservation of momentum, 2,000 times 1.5 is the momentum before, is 3 plus 2, 5,000 times V, which gives you V to be 0.6. So it has to be 0.6 and decreases. The answer has to be B. 27. We have a car of mass 1,000 kilos accelerating uniformly from rest at 25 meters per second in 50 seconds. What's the average useful power? Well, the power, of course, is the work done over the time, which is the change in the kinetic energy over the time. It didn't have any to begin with, so the KE change is how much it has at the end, which is half by 1,000 by 25 squared, divided by the time, which is 50. And if you do all that, you'll end up with the answer being C. '28. Tensile force puts tension delta L in a steel wire of initial length L, diameter D. The same steel, same Young's modulus therefore, is used to make a second wire of initial length 2L and diameter D over 2. What is the extension? Well, E is FL over A little e. So little e then is FL over A big E. That's the same. So the new extension, we have doubled the length, so we have 2FL. The area is D over 2, so the area will be over 4 times the same Young's modulus, because it's proportional to D squared, of course. So that leaves the extension going to 8 times the extension. So the answer then is D. '29. IV characteristic for a filament lamp up to its working voltage. Well, we know that as the current increases, the temperature increases, the resistance increases, and so the graph gradient will decrease. It's B. Question 30. 3 identical cell, HT EMF 1.5 volts and internal resistance connected to resistance R. R is 6.0 ohms, internal resistance 6.0 ohms. So what is the current in R? Well, the current in R depends on the PD across these cells, which will be down to the internal resistances. So what you have is 3 internal resistances in parallel. So your total internal resistance would be 1 over R plus 1 over R plus 1 over R. So your total internal resistance would be R over 3, which is 2 ohms. So your total resistance in the circuit then would be R plus the total internal resistance, which is 6 and 2 is 8 ohms. So the current then is V over the total resistance, that is 1.5 divided by 8, which gives us an answer of 0.19. We're now on 31. Power 100 kilowatts, potential difference 10 kilovolts, load resistor through cables of resistance 5 ohms. So power is V times I. So I then is P over V, which is 100 kilowatts divided by 10 kilovolts. So that gives us 10 amps. The power loss in the cable then is I squared R, where R is the resistance of the cable, 5 ohms. So we have 100 times 5, 500 watts, and we have 0.5 kilowatts, so the answer is B. 32. X and Y are connected in series with a 6-volt battery, 6.0 volt battery, negligible internal resistance. X has a resistance of R, Y a resistance of R over 2, voltmeter resistance R. So what we have here is R and R over 2 in parallel. So the question is, what is the resistance of this? So our total resistance with the Y and V in parallel will be 1 over R plus 1 over R over 2, or 2 over R, which of course is 3 over R. So the total resistance between those 2 points is R over 3. So you've got R and R over 3. So you've got 3 R over 3 plus 1 R over 3. That's R. So 3/4 of the PD dropped here, 1/4 of the PD dropped here, and 1/4 of 6 is 1.5. which means the answer is B. (33). We have the voltmeter halves, the reading of the voltmeter halves, which is closed. What's the internal resistance? Well, this is reading the EMF. And then half the EMF is dropped across the internal resistance when you close the switch, and half of it dropped across here, which means the resistance, internal resistance, must also be 2 ohms C. 34. All right. In the circuit shown, a PD of 3 volts is applied across X, Y. What's the current in the 5 ohm? Well, you've got 3 volts across 8 ohms, so the current would be 3 over 8. which gives us A.